This is 8th grade lesson 3.3. Our objective for this part of the lesson is students will write an equation from a real world problem. The standard covered is still 8F4. The page numbers out of the hardcover book are 118 through 123, and out of the practice journal, you'll be using page 66. Okay, today we're going to work with writing equations from a word problem. Yesterday we worked where they just gave us coordinate sets, and we went through and graphed out those coordinates and wrote out their equations. Today what we're going to do is we're going to learn how we can actually go through and write out an equation without actually having to graph it out. So we'll start with our first one with graphing it out so that you can see, but sometimes that's not very practical because it takes more time to write out the graph than it would be to be able to solve it in a different manner. So here our scenario is we have a 2-week-old kitten that weighs 9 ounces. 2 weeks later, it weighs 15 ounces. Write an equation to represent the weight, y, in ounces of the kitten after X weeks of birth. How old is the kitten in the photo? So we're going to start out, first of all, with writing out and drawing out, sketching out the information that they gave us. So we have at 2 weeks old, the kitten weighs 9 ounces. So we're going to do, looking at our little coordinate set, this is going to be our weeks, and this is our ounces. Okay, so at 2 weeks, it is 9 ounces. So I'm going to go over to 2 and up to 9, which falls in the middle of our box there. And then it says 2 weeks later. So that means if it was 2 weeks later, it would be 4 weeks, right? So 4 weeks, it now weighs 15 ounces. So I'm going to go over to 4 and up to 15. Okay, now you can kind of see why I said it's not very practical to always use a graph, because first of all, I had to modify my coordinate plane here. And sometimes it's just confusing to read it even after you plot it. So if I were to go through and actually connect my dots here, I can see that somewhere it's crossing between 4 and 2. So it's probably 3 ounces when it was born, because that's our line 0 or our week 0 when it was first born. But we're going to go ahead and draw a table so that we can for sure identify that out. Okay, so here's my table. And the information that I had originally was at 2 weeks old. So I need 0 week, 1 week, 2 weeks, 3 weeks, 4 weeks, and so forth. Okay, and I could do 5 and continue it if I need to. Okay, so it says at 2 weeks, it was 9 ounces. So this is my weeks, this is my ounces. Okay, these are my X's and my Y's. So at 2 weeks, it was 9 ounces, and 2 weeks later, which would be week 4, it was 15 ounces. So the change here was 6 ounces over the 2 weeks. Okay, so what would it change each week? Well, that's our slope, or our rate of change is 6 over 2, which would be 3 ounces per week, right? Okay, so that's when we write our y-intercept, it's changing 3 ounces each week. So that's our 3 times the number of weeks. And then we have to figure out how much it weighed. Now I can go ahead and fill in each of these. So here, if I added 3 to my 9, that would give me 12 ounces at week 3. And then if I added 3 to my 15 at week 5, it would be 18 ounces. So I'm going to now work backwards for these. So 6 ounces and then minus 3 more ounces to week 0 would mean that it weighed 3 ounces at the beginning. So I was right when I had my graph and I said, well, it looks like it crosses at 3. So that would be plus 3. So that's our y-intercept equation. Now it says, how old would the kitten be in the photo? So looking at our picture, cute little kitten, it's 22.5 ounces. So I could go through and continue my table and work out, but I'm noticing that as I'm looking at these, they're all whole numbers. I have nothing that's a decimal number. So what I'm going to do is I'm going to go ahead and substitute in my equation that I have over here, this 22.5. And that was my y, or my ounces, right? So where I have y, I'm going to put 22.5. So 22.5 equals 3x plus 3. And we practiced this a little bit in our previous activity. So if I want to work to get x by itself, I would do minus 3. So now I have 3x equals 22.5 minus 3 is going to give me Let's see, minus 3 would be 19.5. Okay, so now we'll go ahead and divide by 3. Divide by 3. So if I pull my calculator out and I do 19.5 divided by 3, 19.5 divided by 3, it gives me 6.5. So that means that this kitten is 6.5 weeks old, or 6.5 weeks old. So that's going through and using a graph. But like I said, it's not as practical to use the graph, because looking at this graph, I could continue my line, but once again, that line, it's not going to cross at 22.5 anyway. It's going to be off of my graph. So sometimes using a table like we did here is just as easy as graphing it out and writing our y-intercept. We just have to learn how to find our slope off of that and then work backwards to our 0. Like in this case, it was week 0. So we're going to practice using just a table on these next ones. Okay, so let's go ahead and look at this one. Okay, so we're back to that same scenario. It says a 3-week-old kitten weighs 12 ounces. So I'm going to draw a table. And our X's and our Y's is usually how the tables are set up. And we said 3-week-old. And we have to remember that when we do our table, we always have to work back to the 0. So this would be 2 weeks, 1 week, 0 weeks. And at 3 weeks old, it was 12 ounces. Okay, so this is our ounces and this is our weeks. 2 weeks later, so 2 weeks later, if I go 2 boxes up, that would be week 5. It weighs 18 ounces. And how old is the kitten when it weighs 27 ounces? So we could continue our table to get all the way to 27, but we're gonna substitute in. So if we go through and look at this, well, it changed 6 ounces over 2 weeks. So our slope, our rise and our run, remember it's always y over x. So our change was 6 over 2, which would be 3. So our slope was, or slope part of our equation is 3, and then x. And now we have to find out where it's going to cross the y-intercept. So I like to fill everything in. So if it changes 3, that would be 15 ounces. So minus 3 from 3 to 2, minus 3 from 12 would give us 9. Minus 3 would give me 6, minus 3 would be 3 ounces. So it's the same equation that we just had. So it started out at 3 ounces when it was born at 0 weeks. Now they want us to figure out at 27 ounces, how many weeks old would that be? So since our ounces are our y's, we're going to put 27 where y is. And we're going to solve our equation. So it's a one-step equation, solve for x. So minus 3, we get 24 equals 3x, divide by 3, divide by 3. 24 divided by 3 is 8. So it would be 8 weeks old. Our X is our weeks, remember, so 8 weeks would be how old that kitten would be if it was 27 ounces. Okay, so that's working. And we could have continued the table also if you're more of a visual person, but that once again is not always practical either, because as we noticed on the previous problem, sometimes you have decimals where it falls between 2 of them. So you have to understand how to be able to substitute in like we did here and solve for a variable, which you're capable of doing. That is just understanding that you can substitute in sometimes. Okay, so let's go ahead and look at our next one. Once again, we're going to set up a table. So it says jet skis. It costs $175 to rent a jet ski for 2 hours. Okay, so table. So I've got 0 hours. Remember, we always have to work to 0 because that's our y-intercept. 1. So at 2 hours, it was $175. So hours, and these are our x's, and dollars, which are our y's. Okay. It costs $300 to rent a jet ski for 4 hours. So we skipped hour 3, but at 4 hours, it was now costing us $300. So we need to find out what our change is here. Well, the change was 2 hours. And here it changed from 300 to 175 as it went up $125. So our slope could be 125 over 2. So we could do that. Okay, but most likely you're probably not going to think in terms of 2 hours. In this real world scenario, you probably really want to know how much you're paying per hour. So let's go ahead and figure that out. If we paid $125 for 2 hours, so how much would that be an hour? Well, 125 divided by 2 is going to give us 62.50, 62.5. So 62.50 per hour. Okay, so now we need to find out what that y-intercept is. Okay, so if I go through and I fill in the rest of my data here, let's see, $300 minus my 62.50, which I don't really have to have this one in there, but I like to see it all. So if we rented it for 3 hours, it'd be $237.50. So now we'll work backwards. So 175 minus the 62.50 gives me $112.50. So that's just for 1 hour. So now if I subtract off the 62.50, that means that even when I start out, I'm going to have to pay $50 at hour 0. So in other words, that means you're paying a $50 fee and then so much per hour of use for that jet ski. So here's our y-intercept, would be $50. Okay, so there's our y-intercept equation. We could then continue. Let's say I wanted to rent it for a whole 8-hour day. I'm having family up. I just want to rent it for the whole day. I could go through and figure that off of my equation. So if I was going to rent it for 8 hours, well, y equals 62.50 times my number of hours, and I'm still going to have to pay the $50 fee. So if I was going to rent it, and I know this wasn't part of the question, but just so you understand, like, where you would use that equation is I would do 62.50 times the 8 hours would be $500 just for the renting. And then I still have the $50 fee. So if I wanted to rent it, if my family was coming up for the day and we wanted to rent the jet ski, it would cost us $550 to have it for an 8-hour day. Ooh, that's pretty steep. Makes you want to be in the jet ski renting business, but not the one having to rent it. Okay, so let's go ahead and try one more. And this time we're going to be working with a scenario of a car. So this is something that will probably fall into play for many of you in the next few years. So it says car value. The value of a car decreases at a constant rate. So the key thing is it decreases, it goes down in how much it's worth. It says after 3 years, the value of the car is $1,500. So here's my table. Remember, we guys have to work the table out to 0. So this is my years. So that's my X's. And then my dollar amount, which would be my Y's. So 0, 1, 2, 3 years so far is what they're giving me. So at year 3, it was worth $15,000. Then it says after 2 more years. So 2 more years would be year 5. It is now only worth $11,000. Okay, so year 4, what I want you to do is I want you to go through and figure out what was your rate of change. Okay, so it changed in dollar amounts by 4,000, but it changed here in 2 years. Okay, so what I want you to do is pause your video and see if you can figure out your rate of change. And then once you get that, work to fill out this bottom part of the table and see what your y-intercept is. So go ahead, pause your video and work your way through this. Okay, So you should have ended up, and the key thing on this is working your way backwards to zero. You guys have to remember that you're doing the opposite. So although it was dropping $2,000 per year, when you work back to zero, you're adding that 2,000 because at year two, it would have been worth 2,000 more. And at year one, it would have been worth 2,000 more. So at year zero, it was a $21,000 car. So that means that you bought that car for $21,000. And then each year it depleted by 2,000. So let's say you wanted to figure out at what point would it balance out. In other words, is it going to be worth $0? Now, ultimately, it probably will never really do that because there's not really that effect of always working exactly dropping $2,000. And it's always going to be worth something unless you total it and it's sitting in a junkyard. Then it's at least worth scrap metal. But anyway, let's say we wanted to figure out that if I were to buy it for $21,000, how many years would I need to drive that for it to say that it's now worth, I've already driven it worth its $21,000. Well, we want to figure out then at what point will Y be worth zero. So this is just doing another extension off of that. So if it's going to be worth $0 minus 2,000, X plus 21,000. Okay, we're going to work this backwards. Okay, we want to figure out at what year would it be worth $0 according to this equation. So minus 21,000, we want to work to get X by itself. So now we have negative 21,000 equals 2,000 negative, X. So we'll divide by negative 2,000. Divide by negative, 2,000. Okay, so let's see, 21,000 divided by 2,000, and I know two negatives make it a positive. It's 10 and a half, 10.5. So it would take us 10 and a half years to fully deplete itself or say that it's now worth $0. But like I said, that's not practical. It would still be worth something. But if we were to follow that equation, that's what it's saying, is that in 10 and a half years, it's going to deplete itself out. Okay, that's it for this lesson. So once again, in this lesson, just identifying for you that sometimes it's not practical to draw out a graph because it takes more time to actually fill in the graph than if you were to use a table. But then understanding that from the table, you have to understand how to find your slope. And your slope is going to be your change in your Y's over your change in your X's, which we have worked with that in the past. And that's where I visually kind of showed you here how much did it change over that amount of time, because on a lot of these equations, it jumped boxes and left a space in the middle. Your slope is always going to be your rate of change over a period of time. So good luck with this one and just keep plugging away. I know they're kind of difficult problems, but you just have to keep plugging away and trying and continuing to try and get better at them.